In this problem, we have a system of inequalities, and the way you solve a system of inequalities is a graphical solution. So what we're going to do is graph each of these, and wherever the shaded regions overlap, that will be the solution to our system. So we'll be graphing x minus 3y equals 6, and I'm going to graph that using intercepts. We'll do that first. The x-intercept will be x equals 6 is where it will cross the x-axis when y is equal to 0. When x is equal to 0, y would have to be equal to negative 2, so that negative 3 times negative 2 equals positive 6. So that means I have a line, because it's just greater than, it's a dotted line that passes between or through these points. Now if I wanted to test point, I could test the origin to see if 0 minus 3 times 0 is greater than 6. But no, 0 is not greater than 6, so I would not shade the side on the origin. I would shade down. And for now, I'm just going to put small arrows to show which direction, so that when I'm done with my second graph, I can see where the two overlap, and that's the region I will shade. So the second equation I'm graphing is 2x plus 4y equals 8. So when y equals 0, x would equal 4. And when x equals 0, y is equal to 2. This time it's less than or equal to, which means I have a solid rather than a dotted line. So a solid line that passes through this region. And I could again choose the test point of 0, 0 to see that 0, 2 times 0 plus 4 times 0, is that less than or equal to 8? Yes, it is. So that tells me in this one I'm going to shade in this direction. So what I'm looking for is the regions where these shades overlap. So for here I shaded down, and here I'm shading to the left. They're both shaded below the dotted line where it intersects with the solid line, so that this lower region here is the solution to both systems of equations.